In fourth grade, my favorite computer game was Number Munchers. The gameplay was simple. You controlled a green muncher character by pressing keys on the keyboard. The goal was to get your muncher to chomp on numbers that met a specific condition. For instance, all prime numbers, or all numbers that were multiples of 5, etc. You did this while also avoiding the deadly Troggle monsters which roamed the grid. My teacher told me I could make games like this one day if I became a computer programmer. I was sold, and that's when I began my journey into the wonderful world of programming. Hi, I'm Anise Davis, a software industry veteran, and I'm thrilled to help guide you on your programming journey. In this course, we'll go behind the scenes to understand what programmers do, how they do it, and how you can learn to do the same. What's more, I'll walk you through your first line of code, explain the core concepts needed to write programs, and take a peek at several programming languages along the way. If you've heard of programming and had no idea where to start, this course is for you. I hope you're ready to join me on my LinkedIn Learning course all about getting you started with programming. Computer programmers are the hidden force behind the technology you interact with each day, whether making a phone call, playing a video game, or joining a virtual meeting. If I were to ask you, what does a computer programmer do? You might say, they code. And you'd be correct. However, there's much more involved than simply coding. Computer programmers design, develop, and test software. Software encompasses the programs and operating instructions used by any computing device. Your phone, a laptop, even an airplane all contain software. Computer programmers ensure that the software adheres to best practices in performance, reliability, and security. This allows you to go about your daily tasks confident that your devices will behave as expected. But how do computer programmers know what to develop? Well, it's based on the needs of the software. For example, let's say they work for a banking app. They receive a request to support a new transfer functionality. First, they will work with others on their team to determine what software should be developed. This typically involves many iterations of design, development, and testing to ensure everything is working smoothly and as expected. Then, using their expertise, the computer programmer would write code that the computer can understand to handle the new functionality. However, programmers don't only get to write new programs. They often have to work on ensuring the health and reliability of existing programs. Let's have a brief history lesson to see why this is critically important. In 1999, billions of dollars were spent worldwide to upgrade computer programs. Why? because of a computer bug or malfunction known as Y2K. Y2K is the shorthand term for the year 2000. As the year changed from 1999 to 2000, programs that represented four-digit years with only the final two digits would start to report the year as 1900. Unbelievable. Programmers worldwide had to scramble to update countless software to avert a major international crisis. Now, that's certainly not a typical day at the office. However, it underscores the importance of maintaining the health of existing software. Programmers spend more time reading code than they do writing it. Does that surprise you to know? This field is full of twists and turns. No 2 days are the same. But that's part of what I personally love about being a computer programmer. A computer programmer can be involved in many different activities on a typical day. To get a sense of what those activities include, let me take you through a typical week in the life, starting with Monday. This is when we prepare for the week ahead. It involves meeting with our team to discuss this week's priorities. Many software companies deliver features to users one at a time. There's often a list of features and bugs that the team must prioritize. It's important to understand that one single programmer rarely develops software. We work as a team and need to agree on what each person will do to help achieve the goal of delivering a new feature to users. Once a programmer has their task for the week, they can begin researching and preparing to work on the feature. On to Tuesday. Once you've done your research for what you'll need to know to develop a new feature, you can begin to write new code. Writing new code often involves a lot of trial and error. This is where you put your critical thinking and problem-solving skills to use. You may consult with fellow programmers to get ideas on tackling particularly complex problems. Wednesday. You have the basic feature working partially. However, you run into several issues when attempting to run or execute your new code. This is where you will spend time debugging issues. Debugging is the process of finding and removing errors or bugs in your code. These bugs can cause your code to behave oddly or crash. Programmers have various methods available to them to debug their code. On to Thursday. You've spent time finding and fixing bugs in your new code. Now you're able to run it on your machine. Hooray! But not so fast. When your coworker tries it out, they get a crash. Oh no. You missed handling a few scenarios that a real user might do with your code. So it's back to debugging the issues and writing tests to ensure you fixed it properly. Software tests are written using code. They verify that what you developed behaves correctly. It's one way programmers check their work. Finally, we've made it to Friday. This is where you can show your work to the rest of the team. They may have questions on why you took a particular approach, or provide suggestions on how you can improve the new feature. More often than not, you'll also discover more bugs. This will require more debugging and testing on your part. The life of a programmer is never dull. Programming is a career that I love, but that's not to say there aren't bumps you'll face along the way. Here are the top 3 challenges I've seen in this career. Number 1, naming. Some parents spend weeks, if not months, picking the perfect name for their child. They may want a unique name that reflects their culture, or one they believe will make the child more successful in the future. But that's something they only have to do once. Programming involves naming things daily. When you write code, each class, file, and variable can have a name, and the name matters. Naming is a form of communication. It helps convey the purpose of the code, what someone should expect it to do. This is as important as eventually the code may need to be changed. Naming things properly will make them easier to read and understand. Number 2, working with legacy code. You will find various definitions of legacy code online. The definition I prefer is code that you're afraid to change. Why might a programmer be afraid to change code? It could be that the code is not up to date with the latest software practices and design. The original programmer who developed it no longer works with the company, and the code is too complicated to understand. There are no tests, or the tests are insufficient to feel confident in making changes. Working with legacy code can be a real challenge for all of these reasons and more. Number 3, providing estimates. Very few programmers are good at estimating a task duration. The work we do is complex, and often there are various unknowns. However, businesses need to know when their customers can expect to receive the new software or feature. This requires programmers to inform others how long they think it will take for them to complete a given task. Seems simple, no? Well, not quite. A programmer needs to take various factors into account when providing an estimate. How many total hours of coding will they have, minus meetings and other tasks? What type of research is needed before coding this new feature? Will it be easy or difficult to write tests for this feature? Do they need to provide documentation for others? The answers to each of these questions will impact the final estimate. That's why software estimation is often referred to as an art. It takes time and experience to provide reasonable estimates to others. Don't let this scare you. Like any challenge, it's essential to be aware of them so that you can successfully face them all over time. Mark Benioff once said, "The only constant in the technology industry is change." How true. Think about the technology you use every day. It's constantly upgraded and evolving. When I was growing up, I would have never imagined the ability to have a connected device in my home that could control the lights, the TV, even the thermostat. But that's a technical reality today. For programmers, this means a constantly evolving learning curve. So how do we keep up? What can we do to keep our skills sharp? First and foremost, you are responsible for your career. Whether your current job provides you with exposure to new technologies, you must find the time to investigate what's trending in the industry. A straightforward way to do this is to subscribe to a newsletter that shares links to relevant industry topics. The most popular programming languages, frameworks, and industries have several that you can choose from. If you struggle with finding time to read, I recommend subscribing to podcasts that cover the latest in the industry. For example, if you're into cybersecurity, they have podcasts for that. Mobile development? No problem. Podcasts have you covered. You name it, There's probably someone with a podcast about it. Besides that, you should also consider working on a side project. Side projects are simple programs that you develop to explore a new technology in your free time. Some programmers need their free time to completely disconnect from their computers. I respect that. But if you're the type who prefers to use it for learning, then a side project is the way to go. So far, we've talked about things you do on your own. But one of my favorite things about programming is the tech community. There are conferences, webinars, local events, and more in the tech community where you can join with other programmers to learn about new technologies together. These events typically provide an introduction and get you excited about exploring more. Sound like a lot? I'll be honest. Sometimes it can be. But at the end of it all, programming is about solving problems with technology. So if you keep your mind sharp and continue to think critically, you'll be just fine. Software development involves various processes related to software design, development, and delivery. Recall, software is the set of instructions or programs that tell a computer what to do. There are three basic types. System software to provide core functions, such as operating systems or hardware management. System software often runs in the background and doesn't require the user to interact with it. For instance, you might be watching this course on a Windows machine running the Windows system software. Next, application software or apps. These help users perform a specific task. Apps are often installed by the user and become active when the user takes a certain action. Some examples are e-commerce web applications where you can make a purchase, or mobile applications that allow you to share and like pictures, or a chat application that keeps you in touch with coworkers. The third basic type is programming software. This software gives programmers the tools they need to create code. Programmers need a place to write, test, and package their code for use. To do this, they make use of programming software. Software development is a diverse field. In what ways? Software is used in virtually every aspect of our lives. Some of its applications are free, others paid. Software is written in thousands of programming languages by programmers with various specialties and experience. The process of software development varies from company to company, team to team. Regardless, the demand for software development continues to increase worldwide. Familiarizing yourself with it now will prepare you for future success. Did you know the Microsoft Windows operating system has roughly 50 million lines of code? Now, that's a lot of software. 50 million lines of code? There's no way they wrote all of that at one time. So how did they do it? Well, software is developed in various phases known as the Software Development Lifecycle, or SDLC. This process allows companies to produce software of high quality in a timely, efficient manner. There are 7 phases of the SDLC. Let's walk through them together. The first is requirements gathering. This is where certain members of the software team work to understand what is needed by users and the business. They may conduct interviews, hold workshops, or research competitors to provide the direction for the project. The second phase is analysis. This is where team members begin to focus on the portion of the requirements that they plan on implementing, identify any risk to the project's success, and document the high-level goals. Third, design. This is much more than what a user might see on the screen. This is the system's design of how the various components will fit together. You can think of it as a blueprint for the programmers to use during the next phase, which is coding. In this phase, programmers start to build the software by writing code using the chosen programming language. It is typically the longest phase of the software development lifecycle. Next up is testing. We don't build cars and just put them on the road. That would be disastrous. Once we build software, we don't just give it to users. Instead, we make sure it's tested. During this phase, bugs or defects are found and communicated to the programmers. They then work to fix the bugs and have them retested. This process continues until the software is bug-free. Which brings us to the next phase, deployment. The software is now available to users. They might download it in a mobile app or access it online via a website. This is when programmers start to do their happy dance. And finally, we have maintenance. Now that the software is in users' hands, additional bugs may need to be fixed or minor adjustments made. Bugs, you say? Yes. The way customers use the software is not always the same as how the team envisioned it. Therefore, it's normal to make updates from time to time after software has been deployed. And that's it, the entire software development lifecycle. Did you realize how much was involved in developing software? I hope you've gained a new appreciation for the behind-the-scenes work that goes into the software you use every day. Programmers aren't the only ones involved in creating software. Recall, the software development lifecycle has several phases. In each phase, one or two key roles drive it forward. Let me introduce you to the development team. Meet the business stakeholder. As the stakeholder, he is accountable for the project budget, direction, and its ultimate success. As a result, he has a considerable influence on what features the team develops. Next, I'll introduce you to the team's product manager, or PM. As the PM, she works with the stakeholder to define the user needs and set the product roadmap. She also works closely with the programmers and designers to deliver features. Speaking of which, here come the designers. They work as the user experience and user interface designers respectively. As the user experience designer, he is responsible for ensuring the software we develop is user-friendly. In addition, he does user research and stays up to date on the latest guidelines for human-computer interaction. In comparison, the UI designer works to provide the styles, graphics, and user interface elements needed by programmers. I know you've been patiently waiting to meet them, the programmers. This team has 3 programmers. They each specialize in various layers of the system. First up is the front-end programmer. He handles what the users see and interact with. Then there's the back-end programmer. She focuses mainly on the software rules known as business logic. And finally, the full-stack programmer. They can write code for any system layer. Last, and certainly not least, is the quality assurance engineer. She is responsible for ensuring the quality of the software that is developed. She tests the software under various conditions and ensures it behaves as expected. As you can see, software development is a team sport. We need each person to do their part to succeed. Various tools are used in successful software projects. A tool can be used for each phase of the software development lifecycle. I'll walk you through the most common tools you're likely to encounter starting out. We'll start with the whiteboard. A whiteboard is great for brainstorming ideas, visualizing project components, and collaborating on a problem with others. I don't think I've ever been to a tech company's office that didn't contain several whiteboards. Even if you work on a project virtually, you can still use online whiteboards to get the same benefits. Next up, online collaboration software. Companies like Microsoft, Google, and Atlassian provide software that allows a team to collaborate on files together. This is vital for software projects as requirements need to be documented. Systems need to be represented visually, and presentations need to be created for stakeholders, and much, much more. Being able to collaborate on these files as a team is critical. Moving on to project management software. This allows the product manager to plan software projects and keep them on track. If you think about an app that you use every day, it's no doubt made up of several screens with lots of actions that you can take. Keeping track of each screen, button, and action could get complicated. The project management software allows you to define each task of a project, assign it to the appropriate person, and monitor the time it takes to complete. Depending on the size of your project and the company's budget, your project management software can have relatively few features or be highly configurable. Programmers rely on the project management software to help them identify what they should work on next. Integrated development environments, or IDEs, are used by programmers to write code for the project. Similar to project management software, IDEs can be simple or come with numerous features to aid a programmer in developing software application. Finally, there's good old-fashioned paper and pencil. I keep a notebook on my desk that I use to sketch simple designs, jot ideas, and outline system interactions before I begin development. Once software is up and running, the next step is getting it to customers. This is one of the most critical aspects of the software development process. Why do I say that? If you can't get the software in users' hands, your project cannot succeed. Worse yet, you fail to adequately protect your software, and it's copied illegally and distributed to non-paying customers. In either case, all of your hard work would have been for nothing. Delivering software to the intended users is known as software deployment. The type of application developed dictates the steps followed during the deployment process. During deployment, the code written by the programmers is packaged, tested, and released so that the desired customers can use it. I've had the pleasure of developing both web and mobile applications. For modern web applications, the deployment process is highly automated. It could look something like this. The programmer writes new code. The new code is tested and no bugs are found. Then the code is packaged into the existing project. And then a new executable is produced. An executable is a file or program that computers can run. This executable is then copied to the internet. From there, users can go to the website's URL and benefit from the programmer's changes. Now let's compare this to a typical mobile application. The process is often a mix of automated and manual steps. The programmer writes new code, and before the chosen deployment date, the code is packaged into the existing project. A new executable is then produced. Next, the new executable is given to the tester. The tester manually checks that the recent changes didn't introduce any bugs. Once that's done, the executable is copied to an app store. App stores help protect the executable from illegal copying and provide a mechanism for delivering the changes to users. And whether it's a web or mobile application, the fun doesn't stop once customers have the software. The development team will monitor the success of the project based on the actions taken by customers. They will also work to fix any bugs they discover once the software is fully deployed. By investing in a streamlined software development process, companies can respond to customer needs quickly and stay competitive in an ever-changing world. Programmers use version control systems to make updates to their code safely. Version control is the practice of tracking and managing changes to software code. Version control systems, or VCS, are software tools that help software teams manage code changes over time. You can think of it as an account ledger. Each transaction, whether it's a deposit or withdrawal, is tracked. And each transaction contains information about the date, the amount, and the payee. Version control software behaves similarly. It keeps track of every change to the code. In a special kind of database, information is stored about what files changed, who changed them, when, and the purpose of the change. Version control is an essential part of a programmer's everyday practice. I don't know anyone who develops without it. But why not? What are the benefits of using version control? First, having the history of changes allows you to go back if you make a mistake. Recall, writing code is a lot of trial and error. You're bound to make mistakes. So having version control is your safety net. Second, it allows multiple programmers to work on the project simultaneously while minimizing conflicts. Modern VCS lets programmers create copies of the code and make modifications that don't prevent the other programmers on the team from doing the same. Then, once everyone is ready, they can safely combine or merge their changes. And finally, having the code changes annotated helps with troubleshooting when a bug is discovered. Like our account ledger analogy, if the balance goes in the negative, you can find out which transaction was the culprit. Similarly, when there is a bug in the code, you can use the log of changes from your VCS to debug the cause. One of the most popular version control systems today is Git. Git is free and open source. It exploded in popularity due to its branching model. A branching model defines the rules for making isolated code changes and then having those changes brought back into the main project. Git's branching model allows you to have multiple local branches that can be entirely independent of each other. And then, Git makes it fast and easy to merge those changes back into the main branch or discard them altogether. It's up to you. Version control systems help software teams work faster and smarter. It's an essential practice of modern-day software development. Repository hosting services are third-party web applications that wrap and enhance a version control system. One of the most popular version control systems today is Git, and the most popular hosting service for Git is GitHub. GitHub lets you and others work together on projects from anywhere. Let's take a look at some of its features together. First, it allows you to store your code in the cloud. This makes it available to you and others regardless of your location. Second, GitHub has a software package registry. The registry helps you to find libraries that are community approved. Third, GitHub has code review built in. A code review lets other programmers on your team share feedback and ask questions about your work. It's an invaluable tool in many organizations to ensure the quality of the code changes. And the final feature I'd want to share is the GitHub workflows. The workflows allow you to create a series of checks that must pass before a new version of the software is shipped to customers. It's a powerful feature that aids teams in delivering software constantly. However, GitHub is not the only player in the repository hosting game. There are several others that offer similar functionality. For example, let's take a look at Bitbucket. Bitbucket is great for teams that prefer a seamless integration with their other planning tools. Similar to GitHub, Bitbucket offers code review. Yet, if you're using their software tracking tool, Jira, you can take additional actions like creating tasks and issues directly in your code review. There is no need to have another system to handle that. Bitbucket also has pipelines. These pipelines allow you to run checks and ship software when everything looks good. And finally, you can receive real-time security alerts while you're developing code that can help to keep your project secure. We've only explored two of the more popular code hosting services, but it should be evident how they play a prominent role in the success of software projects. As programmers, it's our job to develop software that meets a business need. And we often do this with a specific deadline in view. So it wouldn't make sense to write the same code again and again for each different software project we work on, especially if the code is already available and verified by other programmers. This is so common in computer programming that we call code that someone else has written and verified a library. Libraries are essential for modern software development because otherwise, we would solve the same fundamental problems repeatedly. There's hardly any relevant software project that would not depend on software libraries one way or another. There are multiple types of libraries available. Many are used for general programming tasks like reading a file or performing mathematical calculations, while others may focus on graphics like displaying images or editing images. And the list goes on and on. Each library serves a particular purpose. Think of it as a tool in your toolbox. Here are some examples of programming libraries in various languages. First up is Ktor. Ktor is used with the Kotlin programming language. Ktor allows you to make network requests and handle the responses in your application, a common task in programming. Next, let's take a look at NumPy. NumPy is a Python library. It's often used in machine learning to help simplify the processing of large data sets, a handy tool in any ML engineer's toolbox. Now, let's contrast a library with that of a framework. A framework is more than a simple tool. It serves as the blueprint for how your software project should be configured and developed. This is best understood with an example. Next.js is a popular framework for developing web applications. It defines the file structure you should use for your code to get the most out of the framework. It also defines rules when followed that allow your website to load quickly and efficiently. As the programmer, you write the code and the framework does the heavy lifting. Yes, both libraries and frameworks are programmers' friends. They make our jobs easier to do as they allow us to focus on the unique complexities of the current task and leave the everyday parts to them. An IDE, or Integrated Development Environment, is an application that provides special tools for programmers to write, debug, and compile code. Why do programmers use IDEs? Well, you can think of it this way. You could write a letter in Notepad, a simple text editor, if you needed to type a letter. Or you could use Microsoft Word, a powerful word processor. They both allow you to write the letter. But Word comes with features like spell check, advanced formatting, and integrations that make it easier to get the job done. It's the same way with IDEs. They help programmers to be more productive with their daily coding task. Let's take a look at a few.